Alright, let's look at the line integrals. Right, so let's say you have a path curve C from point A to point B, and force F is applied, and you walk along this the curve from A to B. Then we want to figure out the work done by the force using the integral. Right, so let's do that. So work, F is going to be, let's say it's two-dimensional, let's three-dimensional, so it's going to have a component X component F1, Y component F2, and the Z component is F3. Right? Then the work done by the force along this curve C would be just line integral right, along this curve C of this force F, and maybe I should write it this way. How about this? I'm going to do a component, so F1 comma F2 comma F3 dotted with dx comma dy comma dz, right? Which is the same thing as f1 dx plus f2 dy plus f3 dz, right? And the short notation, as you can probably write it as over the curve C, and F dotted with dr, right? Where dr is simply the vector of dx comma dy comma dz. All right. So let's look at a simple example here. All right. So you have a force given, a vector y squared comma x comma 1. Right, then the path is going to go along a straight line from 0, 0, 0 to 1, 0, 0. So which means that you're going to walk along here, along the x-axis. Right, and after that it's going to go up to 1, 0, 1. So it go parallel to the z-axis, so go up here. Right, then after that it's going to go to 1, 1, 0, so it's going to go parallel to y-axis. Right, so you're going to end up here. Right, so this is the path it's going to take. Right, so let's find the work along this path. So here's going to be a work. It's going to be along this path, since it's called path, I'm going to call it P. Right, then you have y squared comma 2x comma 1, then dotted with dx, dy, dz. Right, so which is going to be it's an integral over this path P, y squared dx plus 2x dy plus dz. Right, so let's look at the path, first path here. Right, so we're looking at this guy right here. Right, along this path, x is the only one changing, so dy and dz are 0. Right, so only dx is changing, so you have y squared dx, and x is going from 0 to 1. Right, along the second path, right, x is not changing, y is not changing, only z is changing. So we have an integral, integral from, again, z goes from 0 to 1 dz. Right, and along the third path, only thing that's changing is the y value. So you're going to have a 2x dy, and it's going to go y goes from 0 to 1. All right, and better yet, we can say a little bit more about that. So along the first path, y value is actually constantly 0. So you can see that here, this y squared is going to be 0. So which means that we can just scratch this first integral. All right, second integral, it's easy enough and it's going to stay. And last one, you can see that along the third path here, x value is constantly equal to 1. So we know that the 2x is always equal to 2 along that the third path. All right, so we know that we can easily compute this. So this is going to be an integral of 1 with respect to z. So it's a z from 0 to 1. All right, so this is 2. So it's going to be 2y and going from 0 to 1. So which means that you have a 1 minus 0 and a 2 minus 0. So that's going to be equal to 3. All right. So this is the work done by this force along this path from here to there and there. All right, that's it. I hope that this was clear.